Electricity is something we all take for granted. You know you can just boil a kettle or turn on a TV at the flick of a switch. But have you ever wondered how the electricity got there? I met with Catherine O'Brien and Patrick Crowley from ESB International to find out about the importance of engineering in the generation and supply of electricity. So Catherine and Patrick, we're here today at ESBI in Stephen's Green. Can you tell us a bit about the company?
ESBI, it's a multidisciplinary engineering and project management company. So what that means is basically we provide a range of services to asset owners and developers to take projects through from, say, concept to project delivery and then into construction, operations and maintenance.
When you think of ESBI, you kind of think of an Irish company involved mostly in electricity, but you really are involved in a huge range of projects.
We do a lot of projects internationally, and it'd be from concept to design to construction and to operations and maintenance. And I suppose if the whole works, we have staff that are capable of doing everything.
There's civil engineers, electrical engineers, mechanical engineers, and we work on anything from power plants to wind farms, to carbon management and energy management solutions, and we have a commercial team and a full range of services really.
What about your own roles in the company? What is it that you do?
I'm a civil engineer and I work on the renewables team in the civil and structural engineering department. I suppose I could be working on anything from design calculations to writing reports, going to client meetings, our own internal design meetings with our electrical team, and then I could be asked to just get in my car or on a plane for that matter and go somewhere and see the project being constructed on the ground. So I love getting out of the office and it's great to have the opportunity to do that as well.
Tell me about your role, Paddy.
I'm part of the Power System Studies group. We take on studies that ensure that the assets are maximised, I suppose, from a safety point of view, less power outages, and ensure that they're being used to their maximum advantage. My specific role is 38 kV relay settings, and it's basically protection engineering. If there's a change on the network, we basically have to review the protection settings, and if they need to be reset, we'd have to make sure that they're reset and coordinate and so on. The overhead lines and cables and stuff, it'd be a gigantic version, I suppose, of what you'd have in your house, and just make sure that if there is a fault, that it trips safely and within the standard times as well.
So it's basically like a big trip switch in your house?
Exactly, yeah.
Catherine and Paddy brought me to Mountain View Wind Farm in Cavan, where I could see some of their work in action.
Bigger than I was expecting.
Yeah, they're massive. This is turbine number 5 we're standing at here now.
Yeah.
It's like 100 metres to the top.
100 metres?
To the top of the tip of the blade is 100 metres. The weight of this turbine and all the components standing there is about 200 tonnes. So to put that into context, it's like, say, 3 fully loaded Aer Lingus Airbus jets.
So the foundation is massive, you're saying, and obviously each turbine is a huge structure. Would it ever possibly blow over?
Well, not with our foundation designs. I suppose it could happen if your foundations aren't designed right. Obviously the foundation is a lot bigger than what you can see here beneath the ground.
Underneath us, yeah.
Yeah, it's say maybe 16 metres by 16 metres. So we design it to ensure that it won't blow over or won't fail because of the weight of all these components on it.
There's a lot of logistics then really involved in getting all the equipment here and getting something like this actually constructed.
Yeah, definitely. The tower sections are like, say, 30 metres long, so you need to design all the access tracks in such a way that you can get all the components onto the site and through a lot of small back roads, and you need to make a lot of road modifications.
It's a process then to actually go from, you know, deciding that you're going to build a wind farm somewhere to ending up here, so you have a lot of considerations to make. How do you get to deciding where you're going to build it?
Yes, certainly. So I suppose first of all we have to look at high elevations where you've got high wind speeds, and you look at wind resource maps for the country and you find the windiest places available. But then you have to look at a whole list of other considerations and constraints. If there's an electricity infrastructure network close by to export the electricity from the wind farm, and then you have to look at who owns the land, whether it's suitable ground conditions to build a wind farm in, and look all the other environmental constraints and issues like how close you are to a house in terms of noise reduction and shadow flicker from the turbines before you can decide on a final location.
Good job, you found a very windy spot here anyway, so well done.
It certainly is.
So we get to go inside now?
Yeah, sure, I'll take you inside.
Brilliant. I've never been inside a wind turbine before. Cool.
Yeah, so this is the inside of a turbine, and from here there's a computer system within the turbine that is used to control it, and that can be monitored from a remote station in Germany.
So what you're saying is activity in here can be controlled by a computer in Germany?
In Germany, yeah.
That's amazing.
So it's ESB International. What exactly is the international aspect?
We act as the centre of engineering for the ESB, but we also have clients internationally in 115 countries, so power generation, electricity networks, renewable energy projects. Obviously the ESB has quite a long history of developing power projects in Ireland back since 1927, so we have a lot of expertise and technical skills which we can bring to the table.
That's really something to be proud of, the fact that Ireland is leading the way in these technologies.
The government has a strategy to develop 33% of our electricity from renewable energy by 2020. So the ESB is aligned with this strategy, and we're aiming to provide the same. So as part of that, we're intending to develop over 1,400 megawatts of our electricity from renewable sources.
Catherine, how exactly do wind turbines create electricity?
So as you can see here, the blades are turning and the wind turbine is facing into the wind, and then when the blades turn they generate mechanical energy, and that's converted into electrical energy, and that goes through your underground cables and back to your substation. So the computer program which I discussed earlier inside the turbine, that turns the blades to always face into the strongest wind direction. The wind turbines will cut in and start generating electricity at wind speeds of about 8 miles per hour, and then if it gets too windy the turbine will shut down and stop the blades turning, and that would happen at about maybe 55 mile per hour wind speeds. So it's quite a clever system. It controls it to cut in and cut out depending on the wind speeds.
You were saying now you see a lot of switches here, but what exactly is the function?
Yeah, so basically from your wind turbines, as you go out to our grid transformer now in a minute, you need to be able to isolate that, turn that on and off, and also we're going to need protection there as well. So protection relays, if there's a fault on the system or a fault on, for example, the transformer or on the turbine, it'll highlight here one of these circuit breakers will trip. So it's basically used for isolation and also protection, and if the system needs to be maintained, this is where we turn things on and off.
So Paddy, we're here now at the grid transformer, is that correct?
That's correct, yeah. We have our grid transformer in here and the substation behind us. So our wind is generated at 20 kV, it's coming into our substation and it's going through the grid transformer. It's taken in at 20 kV, stepped up to 110 kV because there's less losses. And we can see here we have an overhead line going to Cavan, and the other overhead line is going to Louth.
And do they go off now directly into people's houses from here?
No, there's other transformers, say at the end of these 110 kV lines, say onto another substation, and then they're stepped down via electromagnetism process all the way into someone's house. So there could be one 10 miles away, and from there we'd step it down to 10 kV. And then it could be going to a housing estate, and then step down to manageable levels that are set out for domestic use, 230 volts or else 400 volts for businesses. Yeah.
Did you find the course quite demanding?
Engineering is it's a tough course. It does demand a bit of extra work maybe compared to some other courses, but there's definitely rewards there and positives. Like the course is really varied. There's the opportunity to interact with people in your class and do group projects, individual projects. You go on field trips, do laboratory, so it's not just sitting in a lecture hall, and it can be quite hands-on. I found that to be definitely a huge positive about it, and really after 4 years you're walking out with a degree that you can get a job without doing any further study, and I think that's a big plus as well. And definitely the degree doesn't take up all your time. I can well testify. Still had a very good time. Yeah.
Is it rewarding then to see your project come to fruition?
Yeah, at the end of the day, that's one of the great things about being an engineer, I suppose. You do all the hard work and the calculations and go to all the meetings and do the desk job, but at the end of the day you get to get out on site and see the fruits of your labour, I suppose, and see something standing in operation, and I think ultimately there's nothing more rewarding than to say, I built that. So.
I hope you've enjoyed learning a bit about how wind energy is generated and how just 21 turbines is enough to power over 18,000 homes in Ireland. and of the work that the engineers of ESBI do to ensure that our electricity is produced in the cleanest way possible.